Hello and welcome. This is a Group 4 project about piezoelectrics. So, piezoelectric effect is an accumulation of electric charge corresponding to the applied mechanical stress. In essence, it means that is a response reaction of a piezoelectric material. When applied a force, it will produce an electric current. Piezoelectric material has to be a dielectric and also non-centrosymmetric, meaning that its net moment of dipole should be equal to 0. Piezoelectric effect is one of the couplings of properties between stress and charge or electric current. There is also a reverse piezoelectric effect. So how it works? Basically, when there is a stress applied on a piezoelectric material, there is a change in its atomic structure. When there is no stress applied, the net positive and negative charges overlap, and therefore there is no net electricity in the material. However, when it's squished or under detention, these 2 points, they don't overlap anymore, therefore producing a net positive and negative charges at the outskirts of the material, causing the electric current. Discovery. Piezoelectric effect was discovered in 1880 by Curie brothers. They demonstrated that effect on several materials, including quartz and Rochelle salt. However, later, the reverse piezoelectric effect was discovered by Gabriel Lippmann, which is useful for the ultrasound, which is basically an alternating current connected to a piezoelectric material, causing it to continuously deform, and the sound of the deformation has a very high frequency, producing the ultrasound.
The main commercial piezoelectric materials. Piezoelectric ceramics are intelligent materials that are frequently employed in mechatronic devices and smart systems. They can detect pressure and tension changes in the surroundings, and they use this to generate electric reactions. A piezo element is a tiny disc of piezoelectric ceramic bonded to a metal plate in a piezo buzzer. A silver electrode has been placed with both sides of the piezoelectric element to allow for electric contact. The entire assembly can be housed in a plastic box with or without a drive circuit. State-of-the-art materials and drivers for new materials. Piezoelectric ceramics are not the only materials that are used. There are other uses for piezoelectric materials, such as piezoelectric rods. They have crystals embedded inside the piezoelectric rods, and they distort somewhat when they come under pressure from cars and or pedestrians on the surface, and they use this to generate energy. Piezoelectric ceramics are also used in ultrasound for ultrasonic transducers, and there are very many different types of piezoelectric materials and uses for piezoelectric materials.
Electricity is that a high voltage can be produced by an external force that acts on the piezo material. This property is used in a variety of applications, including gas grills and lighters. The voltage created by the button being pressed causes the flammable gas to light. Piezoelectric materials are also great for use in applications with a high sensitivity, like telescopes or microscopes. Even the phone in our pockets use the piezoelectric effect. Lots of devices use piezoelectricity, as it allows for a force to be detected or a force to be produced. An example of this are piezoelectric sensors, which are better than traditional sensors, as they are able to detect small pressure changes with high resolution and accuracy. This is due to the tiny changes in the width of the crystals, which are incredibly small. They can also measure rapid pressure changes and respond to that quickly, which is extremely useful for devices like airbags in cars. Piezoelectric speakers are an example of the opposite, where electricity is used to create a force. A series of electrical pulses will create vibrations at different frequencies. Piezoelectric speakers are great as they are more resistant to overloads than conventional speakers. Piezoelectric speakers are used for sonar equipment as well, as they are able to output frequencies up to 100 kHz. Another essential device which requires the use of piezoelectric materials are alarm buzzers.
So our application is an alarm buzzer, and how they work is that they contain a piezo buzzer. What is it, you may ask? A piezo buzzer is an electric device used to produce a sound and is typically a very low-cost product. And they contain a piezoelectric vibration plate which emits sound when a voltage is applied, which makes the piezo element vibrate. Now, the piezo element is indeed a fine disc of piezoelectric ceramic sticked to a metal plate, and there are silver electrodes attached to both sides of this element for electrical contact. With such characteristics, piezo buzzers are regularly used in alarms, warning devices, and automobile alerts. And as they have such a versatility with their sound range, they can be used also as pest deterrent devices. And how they work is an alternating voltage is applied to the piezoelectric ceramic material in the piezo buzzer. And as soon as the signal is applied, the ceramic vibrates rapidly, and it's the vibration that causes the actual sound waves to be generated. And these are the sources.
The innovation we were trying to make is a pavement with piezoelectric tiles that can alert securities when someone enters the restricted area. The diagram on the left side shows the general design of the piezoelectric tiles. So if someone steps on the floor will push the springs and then push the piezoelectric plates to transfer electrical charge to the buzzer for it to buzz. For improvement, we managed to apply the principle of electromagnetic induction. So we added 2 coils of wire to make the connection wireless. Therefore, for people that are authorized to the place, we can just remove the buzzer easily for them to enter. The diagram below shows how the wireless buzzer looks like.